This video is going to show you how to complete page 68 out of your math book. Celeste drew an outline of a building for a diagram she was making and then drew a second one mimicking her original drawing. So I'm going to stop right here and I see the word mimicking. Some of you may not know what that means, and mimicking just means copying. Okay, so she drew an outline of a building, and right here is the original. So that's a building that she is drawing a diagram for. And then she drew a second one that mimics this original. Okay, so there's the original, here's the second one. And what I want you to do is just lightly shade the image of the building, just because I think it will help you. But do it very lightly because you're still going to want to see the grid points. Okay, so there's the original building and here's the second building. Okay, and you'll notice that with this scale drawing that this right here is a reduction of the original. So it's a reduction. And what you should know about reductions is that the scale factor will be less than 1. Okay, because it went from big to small. It's a reduction, so you should know that the scale factor is less than 1. Okay, so we're going to go ahead and label this table with X and Y, and at first you might be tempted to go like this, but that is incorrect, because the two things we're going to be comparing are the original to the second. So you want to go X here and Y here. It's actually a horizontal table, okay? So the original is X, the second drawing is Y, okay? All right, now what I want you to do is I want you to find the height of the original drawing, and here's what you need to do to do that. A common mistake that students sometimes make when they're counting is that they'll start with the dot and they'll go 1, 2. That is incorrect. You basically need to count the spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, notice it matches there, 16, 17, 18. So the height of that original is 18 units, okay? Okay, now go ahead and find its length. Okay, and for the length, do that right now. You should get 6 units, okay? So practice your counting to make sure you're doing it correctly. 1, 2, 3, 4, 5, 6. Okay, now go ahead and find the height and the length for the second drawing. Do it right now instead of copying me, okay? This is what you should have gotten. All right, so I want you to go ahead and I want you to figure out the scale factor, okay? We know that the scale factor is going to be less than 1 because there was a reduction that occurred here. So go ahead and find that scale factor, and please remember to do y divided by x. So for this relationship right here, I gotta go y divided by x to find that unit rate, which unit rate is also the scale factor. They mean the same thing. So the y value was 9, the x value is 18. So I need to get 1 in the denominator. So I'm going to divide by 18. And 9 divided by 18 is 1/2 or 5/10. Okay? So that's the scale factor for that relationship right there. For that segment. Okay, let's go ahead and see right here. Make sure it's also going to be the same exact scale factor. If it's not the same exact scale factor, then it's not a proportional relationship. Okay? So y divided by x, and we go 3 over 6, and to find the scale factor, we would do it just like we would the unit rate. 3 divided by 6 is 5/10. So you'll see right here we have the exact same unit rate. We had taken that x value, multiplied it by 5/10, or also 1/2, you know, same thing. Okay? So the scale factor is also, you know, the unit rate, is 5/10 or 1/2. So this is a scale drawing, okay, because it's the same exact unit rate. the next problem. Lucas drew and cut out a small right triangle for a mosaic piece he was creating for art class. His mother liked the mosaic piece and asked if he could create a larger one for their living room. Lucas made a second template for his triangle pieces. So right here was the original. And remember how the mother wanted him to create a larger one? So here's the second drawing, or the second mosaic, okay? And you're comparing the original with the second. So when you go and you label this table, it's X and Y, okay? So you see right here that it was an enlargement because it went from small to big. So if the scale factor exists, it's going to be greater than 1. Okay, all right, so let's go ahead and find the measurements of the height of that original triangle. 1, 2, 3, 4, 5 units. Sorry, that looks kind of like an S. Okay, and then the width of it. Sorry, we can't determine the diagonal yet, okay? And for future reference, since I know this is a right triangle, the side directly across from the right angle is called the hypotenuse, okay? I'm probably going to ask that again in the future. Anyhow, the width of it is 1, 2, 3 units for that original. And then the second image starts at 0, like here, 0 to 15, so that's 15 units. And then for the width, I can't do that exactly. I have to go, let's see, it's 5, 10 units. Okay, let's go ahead and let's determine the scale factor, okay? So let's find that out here. Remember, it's y divided by x. So for this relationship right here, I'm going to write y divided by x because that's going to help me find the scale factor, also known as unit rate. Y is 15, x is 5. So to find the scale factor, I want 1 in the denominator, so I'm going to divide by 5, 15 divided by 5 is 3. Okay, so I multiplied that x by 3 to get that y value. So now for this relationship right here, I'm going to have to draw it over here. Y divided by x, 10 divided by 10 over 3, 10 divided by 3, 1 in the denominator, so divide by 3, divide by 3. 10 divided by 3 is 3 1/3, or 3 3/10 repeating, okay? So I multiplied this relationship by 3.3 repeating, or, 3 1/3. Same thing, okay? Now you'll notice that they have different scale factors. They have different unit rates. So that means this is not a proportional relationship. This one up here was a proportional relationship because they have the exact same scale factor for the relationships. Here, nope. So it says, does a constant proportionality exist? Again, that's another name for scale factor or for unit rate. Nope. No. If so, what is it? If not, explain. So no, it does not exist because it's not proportional. It's not proportional. And what I mean by it's not proportional, I'm saying that the second image is not proportional to the original image, okay? There is not a consistent unit rate between the second image and the original. Okay? So it says, is Luca's enlarged mosaic a scale drawing of the first image? Explain why or why not. No, it's not, because it's not proportional. There's not a proportional relationship. No, it's not a scale drawing. The two images are not proportional to each other. And you should know that scale drawings are always proportional to each other. So since these are not proportional to each other, this is not a scale drawing.